Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder if paying attention actually changes how things look and feel to you? This is a super interesting question that scientists have been exploring. We often think of attention as a spotlight that helps us focus on what is important, but does that spotlight not only help us see things better, but actually change the quality of what we see, the very feeling or experience of it? That is the deep dive we're taking today with some fascinating new research. This study asks a really fundamental question about our conscious experience. It's not just about whether you notice something, but how the very nature of that experience changes. Imagine you're looking at a shape versus a face. Do they feel fundamentally different? And does that difference change when you're distracted? The researchers here wanted to find out. They were particularly interested in something called Qualia. That's the subjective, felt quality of experience. Think of the redness of red, or the pain of a stubbed toe, or the feeling of looking at a familiar face. They call these qualia structures, basically how all these different qualities relate to each other. So how do you even measure something as subjective as the quality of an experience? Traditional studies often ask people to say yes or no, like did you see the object? But that doesn't tell us much about what the experience was like. These researchers came up with a clever idea. Instead of asking if they saw something, they asked people to rate how similar pairs of things looked. By comparing lots of different pairs and rating their similarity, they could build a kind of map or structure of how those experiences related to each other. It's like trying to map out a new continent by asking people how far apart different cities are. They tested this idea with 3 different kinds of things. First, they used simple geometric shapes, rotated letters like L and T. Then, they used something a bit more complex, like colored discs that were also rotated. Finally, they used grayscale faces. They chose these because in previous research, people were good at telling faces apart even when they were distracted, but not so good with the simple shapes or discs. This gave them a hint that faces might be special. Here is how they tested the effect of attention. They had people do 2 kinds of tasks. In one condition called the single task condition, participants could give their full attention to the main task, rating how similar the peripheral stimuli looked. But in the dual task condition, they threw in a second, demanding central task. This second task was designed to soak up all their attentional resources, leaving very little for the peripheral stimuli. It was like trying to listen to a quiet conversation happening in the distance while someone is blasting music right next to your ear. So in this dual task scenario, participants were looking at pairs of stimuli like 2 letters, 2 discs, or 2 faces that popped up in the corner of their vision. While they were supposed to be distracted by the central task, they still had to rate how similar these peripheral pairs were to each other. They used this rating system to build what they called similarity matrices, which represented the qualia structure of their experience. Now, for the really cool part, the results. When participants were fully attentive, they could map out the relationships between all the stimuli. But when their attention was drained by the dual task, something interesting happened. For the simple shapes, the letters L and T, and the rotated discs, their ability to map out the similarities pretty much fell apart. The qualia structures collapsed. It is like their mental map of these shapes became a jumbled mess. But here is the big surprise. For the faces, it was completely different. Even when their attention was pulled away, their ratings of how similar faces were to each other largely stayed the same. The qualia structure of faces remained intact. The map of face similarities didn't get jumbled. They used a fancy statistical method called Gromov-Wasserstein optimal transport, or GRUBOT for short, to compare these similarity maps. Think of it like trying to see if 2 different maps of the same city are structurally the same, even if the street names are different. GWOT is really good at finding these deep structural similarities. And it confirmed their observations. The structure of face similarities was really well preserved even without much attention, but the structures for letters and discs were significantly disrupted. So, what does this all mean? It suggests that the quality of our experience, the how it feels, is not always dependent on our focus. For complex, evolutionarily significant stimuli like faces, where we've likely developed highly efficient, perhaps even partially automatic processing systems, the qualitative experience might be more robust. Even when we're distracted, the feeling of comparing one face to another seems to maintain its underlying structure, built on things like gender or perhaps other features that are deeply ingrained in our perception of faces. On the other hand, for simpler, more abstract stimuli like geometric shapes, our attention seems to play a much more critical role in constructing and maintaining the qualitative experience. Without that attentional spotlight, the relationships between these shapes, how they are perceived to be similar or different, breaks down. It is like the building materials for the mental map are scattered when attention is withdrawn. This research is really exciting because it moves beyond just asking, "Did you see it?" to asking, "What was it like to see it?" and how that feeling changes. It uses similarity ratings not just as a performance measure, but as a window into the very structure of our conscious experience. The development of their novel interpolation method is also a big deal for future research in this area. Traditionally, many analyses of similarity data have assumptions that don't always hold true in real-world perception. This new method accounts for the fact that experiencing two things at different times or places, even if they are physically identical, might inherently feel different, so their dissimilarity might not be zero. This opens up new avenues for studying consciousness. Now, it is important to remember that this study, like all research, has its strengths and limitations. A strength is that they use the dual task paradigm, which is a pretty reliable way to manipulate attention and make sure it is not just about how easy or hard the task is. They also used some really sophisticated analysis techniques to get at the deep structure of the experiences. A potential limitation could be that even with the dual task, participants might have found ways to partially attend to the peripheral stimuli, especially for faces where the processing might be more automatic. Also, the specific types of faces and letters they used might influence the results. For faces, maybe gender was such a strong cue that it dominated similarity judgment, regardless of attention. For the letters, the study notes that maybe the irrelevance of rotation in their central task for letters might have contributed to some findings. What does this mean for us in our everyday lives? It suggests that our more complex, socially relevant perceptions, like recognizing faces, might be more resilient to distraction than we think. The quality of our experience of faces might be less dependent on our immediate focus, allowing us to still recognize people and process their expressions, even when we're juggling multiple things. But for simpler, more abstract things, our attention really shapes the very nature of what we experience. It highlights how perception isn't just passive reception, it is an active construction, and attention is a key constructor. Looking ahead, it would be fascinating to see this research extended with neuroimaging techniques, like fMRI or EEG. Could we see differences in brain activity patterns for faces versus shapes when attention is withdrawn? Also, exploring other complex stimuli like natural scenes or auditory experiences could reveal even more about how qualia structures are affected by attention. Ultimately, this study is a significant step in understanding the intricate relationship between attention and the very fabric of our conscious experience. It gives us a powerful new way to probe what it is like to see the world, and importantly, shows that the what it is like isn't always as fragile as we might assume. What do you think about these findings? Does it align with your own experience? Let me know in the comments below, and if you enjoyed this deep dive into consciousness, don't forget to like this video, subscribe to RUBIN'S Mind Lab for more science breakdowns, and hit that notification bell so you don't miss our next exploration. Thanks for watching.